Okie dokie, let's make it rain. Can you see the rain off there in the distance? I was jogging on the beach in Pismo when I took that picture. I saw off in the distance, oh, look, it's raining. I had my phone with me, so I grabbed that shot for you. Rain is condensation and then falling. That's just technically what it is. Condensation happens up in the sky, something falls. We call it rain. A raindrop is caused by the collision and coalescence of cloud droplets. Collision obviously means that things are going to bump into each other. Do you know what coalescence means? It means they group together as one. They sort of lose their individuality. Let me give an example of this. If you take two pieces of paper in your hands and you shove your hands together with the two pieces of paper and shove those two pieces of paper together as hard as you can, then pull your hands apart, the two papers maintain their individuality and they fall to the ground. If, however, you took a glass of water and you poured out a little bit of water on the table, so there's a little pool of water on the table, and then a couple of inches away, you did the same thing again, you made another pool of water on the table. So now you have two separate pools of water on the table separated by a couple of inches. Then you take one of your hands, you put it next to one of those pools of water, and you push that pool of water over to the other pool of water. Do those pools of water maintain their individuality? No. That's what coalescence is. So in other words, what's going to happen is tiny droplets of water are going to bump into each other in the cloud. As they do, they're going to grow in size. Eventually, they get so large that they fall to the ground. If you look at this diagram, you can see that the little black dots represent condensation nuclei, extremely small. Then around those, cloud droplets form, which are also microscopic, bigger than the condensation nuclei, but still very, very small. Then you can see the size of a typical raindrop, which is many times larger than a cloud droplet. In fact, inside the raindrop, you can see that there are lots of condensation nuclei that have accumulated in there as a result of all of these cloud droplets bumping into each other and coalescing. Take a look at this diagram. At the top, notice it's showing you the growth of cloud droplets due to condensation. In other words, in the top part of this slide, what's happening is the air temperature is dropped to the dew point temperature, the relative humidity is 100%, the air is saturated, water begins to squeeze out onto the condensation nuclei. As that happens, more and more cloud droplets are formed, the cloud becomes visual, and the cloud droplets, especially as the cloud begins to get denser, begin to bump into each other. Here's where this is happening. Collision, bumping into, and coalescence, grouping together. Each time that happens, the cloud droplet itself gets larger. If you continue to make that happen, in other words, more water continues to squeeze out, so the cloud is denser, which just naturally causes greater interaction and collision and greater coalescence, eventually what happens is the droplet gets so large, it's no longer buoyant and it falls to the ground as a raindrop. All rain is formed like that. So imagine the next time there's a really large storm going by. Lots of rain pouring. Every single one of those drops is formed just like that. Take a look at that cloud. I took this picture in Wyoming about 8 years ago. I was driving and there was like a 30,000 foot high cloud. And I was taking pictures of it because there was a storm happening right in the middle. You can see not only is the cloud dense because it's dark, but in addition to that, you can see that rain right there falling out of the cloud. All of that rain is all happening the way I just described. Now, there's also something called acid rain. This is formed when the condensation nuclei are some type of highly acidic substance like a chemical or fossil fuel emission. In other words, something that comes out of the back of your car or out of an airplane or out of a smokestack or out of your barbecue. In order to understand this, we have to go through a little bit of what the pH scale is about. pH, if you want to technically know what it means potential hydrogen, but you don't need to know that. Anyway, the pH scale describes the corrosiveness of a substance. In other words, how likely is one substance when it's applied to another substance, how likely is it to dissolve or destroy or alter that substance? The pH scale is a 1 to 14 scale. 7 is more or less in the middle, and it's completely non-corrosive. 7 is distilled water. Distilled water means you boil the water, you recondense it, all you have is the H2O molecule. There's nothing dissolved in it whatsoever. No salt, nothing is in it. From 1 to just about 7, substances are considered acidic or acids. And then above 7 to 14, substances are considered bases or basic or alkaline. All of those words mean the same thing. Let's look at it. Here's a kind of fun little scale. You look in the middle, you can see neutral. As you go to the left, acidic, and as you go to the right, basic. So all the way over on the left-hand side at 1, you have gastric acid, which is like hydrochloric acid that's in your stomach. Lemon juice, apple juice. I believe a jalapeno pepper, by the way, is about a 2, 2.5, something like that. Tomato juice, black coffee, milk, slightly acidic. Then you can see an egg. Did you realize an egg was basic? I have chickens in my backyard. They lay eggs all the time. Who knew they were giving me little basic gifts? Little basic gifts. Baking soda, hand soap, get up to 11, we're an ammonia solution. Bleach is a 12. And then concentrated solutions of alkalis. I think Drano is like a 13 on this scale, if I remember correctly. So rain, when it falls, is slightly acidic, even under the best of circumstances. Now, I will tell you, I have tested the rain in Los Angeles before, and on a number of occasions, and I've actually gotten basic rain. So I don't know whether it was something that we were throwing up into the atmosphere. You know, it's a huge city of 15 million people. Who knows what kind of garbage is being thrown up there? But generally, rain, even under the most the cleanest, let's say, of conditions, is going to be at least slightly acidic. And the reason is because the raindrop itself dissolves some carbon dioxide from the atmosphere in it, and carbon dioxide is an acid, so it makes a slightly carbonic solution. Typically, you get rain when it falls from 5 to 6. 6 is not an unusual number to get for a raindrop, so it would be acidic. But we don't call it acid rain unless it gets into like the 3 to 5 category. At that point, now we're talking about acid rain. How do you make that? Well, there you go. This is how you make it. When you have smokestacks that are belching out that stuff, well, I mean, the particulate matter can become condensation nuclei, right? And if it's acidic, it's really going to be heavily acidic. Furthermore, the gases can get dissolved in the raindrop, and that's going to further acidify the raindrop. I know this is a kid's diagram, but it's a really good one. Acidic gases released in the atmosphere, you can see that on the left-hand side, and then you can see sulfur dioxide, nitrogen dioxide, and carbon dioxide, all of which are acids. The gases carry upwards by the wind, and then they combine with the cloud, the rain droplets, and they fall, and then this comes down as acid rain. You can see acid rain destroys plants, which it does, it kills them, pollutes water sources and soil, it really degrades the soil, and it erodes buildings. That's right, all of those things. What are the impacts from acidic precipitation? The picture on the right-hand side is from North Carolina. The picture on the left-hand side is from the Czech Republic. The Czech Republic, Poland, Slovakia, that area there used to be called the Black Triangle under the bad old commie days because, of course, the communists wouldn't let anybody protest. So you just had to let them do what they wanted to do. They burned a lot of coal, and it was a very polluted area, maybe arguably the most polluted place in the world at one point. After communism collapsed in 1989, things began to change. You can see the forest is regenerating there. If you look at the forest on the right-hand side, though, in North Carolina, that forest is dying. This has actually been a fairly substantial problem in California, too, with climate change and bark beetle and all of the rest of these things that are killing off vast stands of forest, which, of course, exacerbates the fire situation. Because when you have dead wood laying around, that dead wood is then going to burn much easier than green wood's going to burn. But both of those are the result of acidic precipitation. On the left-hand side is from a very famous cemetery in Buffalo, where a number of my family are buried. This is not one of my family's graves. But that's a marble headstone. It's from the 1800s. You can barely tell. It says 1854 on it. This is very typical, though. Marble's a soft and porous rock, and acid precipitation dissolves it very quickly. If you went up and rubbed your hand on that headstone, it literally would crumble in your hands. You can see on the right-hand side, there's a million pictures like this on if you Google them, of before-after pictures of statues. This is from someplace in Europe. On the left-hand side, I believe it was taken in 1904. On the right-hand side, it's like in the 1970s. This is also because of industrialization and acidic precipitation. You can see what's happened. It's dissolved the statue.